Hey Algebra, we are talking about solving quadratics, and I'm going to walk you through a few different scenarios. Today we learned all about the quadratic formula, and so this formula here in the middle, negative b plus or minus the square root, b squared minus 4ac all over 2a, that will ultimately find any value of a given quadratic that makes 0. So we're going to practice even more with that tomorrow. But the back is really trying to review like all the different methods we've learned so far. We're not technically using graphing on the back, but that's a main idea that we have been doing. Square rooting is a way of solving, factoring, and quadratic formula, the new one. So let's kind of jump in and look and see how one works. I'm going to do number 13. I think you guys are good on the other 3, and then we can check those later. First thing I want to do is try to isolate the variable. And I've talked a lot about like when do you do this. You should notice immediately that all of these problems are similar in the sense that they all only have r squared, v squared, x squared, a squared. There's no you have the quadratic term, but there's no other variable in there. Something like this, for example. See, when you have two different variable positions, that's what makes quadratics harder to solve. Like you need factoring or graphing or quadratic formula or even completing the square, one that we'll do here in a little bit. But see, 9, like the one right here, I could add 25, I can divide the 9 over, and then I can square root both sides to get plus or minus whatever. There's certain problems that are quicker because you can use square rooting as a method of solving, which is like all the other methods of solving, trying to get the variable alone. So in this one right here, I wanted to start by subtracting 4. And so if I start by subtracting 4, 67 minus 4 is 63. You don't want to square root early because we really just want that one side being squared. And right now there's a 3 here in front. So let's divide 63 over, or 63 by 3 to get 21 on the other side. And then when I square root 21, I mean, you can obviously put this value in the calculator to see what that value is. Square root of 21 is 4.58. And this value can be rounded, but then you change the answer. And so honestly, like plus or minus the square root of 21 is perfectly fine. This is an exact answer. And there's no way to break up 21 using perfect squares. For example, if the number had been 24, well, that would have been 4 times 6, and 4 is a perfect square. So you could have simplified the radical. Or if it had been 200, well, 100 times 2 is 200, and so forth. So if it's just like this, you can't really do much. So you can just say plus or minus whatever the square root of 21 is. Once you try these other ones, and they're all very similar, they should only take you just a few seconds to isolate the variable using square rooting. So factoring is another way that you can solve for these 0 points. And 15, just like we have been talking about on the other page, this could be another conversation for using square rooting. You could add 25 over, square root both sides, and that would be the same as if you used what's called difference in perfect square factoring, r plus 5, r minus 5. These two factors create r squared minus 25 if you multiply them together. Well, then I can just think, well, what value for r makes 0? Well, negative 5 plus 5 is 0. Just like if I had the value 5 and plugged it into the other value, 5 minus 5 is also 0. Now, anytime you make either value 0, they're multiplying to make the whole problem 0. So that is why factoring, it can be also another method if you recognize it to be factorable. So for example, in number 17, we really don't want to think about solving a quadratic that has both n squared and n without trying to get equals 0 first. This is kind of this is what makes this different than solving a lot of other equations where you can get the variable alone. And so that's what we're going to need to understand about this chapter, is that we're trying to get the variable solved for, but you really start by getting everything on one side. So once I have everything on one side, I think about what would multiply to be -6 while adding to be this -1 that's in front of the b term. And so that would be n minus 3 and n plus 2. We'll then figure out what values make those 0. 3 minus 3 is 0. Negative 2 plus 2 is 0. So that would be the two zeros or solutions for number 17. So think about 35. Think about what numbers would multiply to be 35 and add to be negative 12 to build your terms. But then figure out what would make each of those 0. And that would ultimately solve the problem. But make sure you have equal 0 to begin with. Last section, we're going to solve each equation here using the quadratic formula. And so I'm going to do 19 and 21 for a moment. First thing you want to understand is how to identify A, B, and C. A is 10, B is negative 3, C is negative 3. So we are plugging that into this formula that I was talking about earlier. This is a very famous algebraic formula. Every student of algebra has to learn this in every course around the world. So let's check it out. So once we figure out where everything goes, for example, this starts with negative b. Negative is going to make that very first term positive. And then we have b squared minus 4 times a times c, all divided by 2a. And that ends up giving us 0.72 and negative 0.42. So really wanted to take a moment just to show you that this value here has to be calculated, and this value is called the discriminant. And we'll talk more and more about what this value can tell you later. But that's why we don't type it all in at the very beginning, especially since sometimes you can simplify that radical instead of trying to get a decimal. So please, please, please try to calculate that number before you find the two answers. In 21, it's not the same as number 19 in the sense that you do not have equal 0 yet. So that's the first thing that I would tell everybody we got to achieve. So I would start by subtracting 7n over, subtracting 78 over, and that would allow us to have equal 0. So I'm going to start by negative b. That value always changes sign there because in the formula there's a negative there. And so now what I want to do is plus or minus the square root of this b squared minus 4 times a, which is 1, and c, which is negative 78, all divided by 2 times 1. So this discriminant value comes out to be 361. And if you do 7 plus and 7 minus and divide, you end up getting 13 and negative 6. Now, because you got integers here that are rational values, anytime your answer is not some type of crazy irrational value, that means that your problem to begin with could have been factored. So if you think about what would multiply to be negative 78 and add to be negative 7, could take you a moment to find that those values are negative 13 and 6. Negative 13 plus 6 gives you negative 7, and these also multiply to be negative 78. But what makes those 0 is 13 and negative 6. So just know that factoring is a faster way once that skill is established, but the quadratic formula will always yield the correct answer. So some students just really master this formula and they're really quick with it also. So I'm going to give you guys 20 and 22 to show me what you got. Of course, 22 looks pretty intimidating, but I would first try to combine like terms and try to get all of your values over on one side so that you ultimately have equal 0. Because the quadratic formula is a no-go when it equals like 4 or 78 or whatever. You have to get everything on one side and then figure out what A, B, and C are, plug it in, and check your work tomorrow.